Hello everyone. In this lecture, we are going to discuss about an example for direct conversion of regular expression to DFA. The problem is construct a DFA directly from the regular expression A B star bar AB. The first step is construct syntax tree for the augmented regular expression. It means construct the syntax tree for the given regular expression followed by hash. So first we need to construct the syntax tree. So first, the parenthesis expression must be constructed. Okay, so for here, the highest precedence is given for star. So first, we have to construct syntax tree for star. Star is the interior node and its child is B. Then the next higher precedence is given for the concatenation. So here A is concatenated with B star. Okay. So for this concatenation node for our cat node, A is the left child and this B star is the right child. Okay. So for this concatenated node, concatenation or cat node, left child is A and right child is the already constructed subtree. Okay. Now we have constructed syntax tree for this sub-expression. Okay. Next, concatenation must be constructed. Then only OR operation must be evaluated. Okay. Or the union operator has the lowest precedence. So next, concatenation of A and B must be done. Okay. So concatenation, its left child is A, right child is B. Okay, then OR operation. For this OR operator, this entire sub expression is the left child and this is the right child, right? So for this for this OR operator or vertical bar or union operator, left child is this concatenation node, this cat node, and right child is this cat node. Okay, then this entire expression is concatenated with hash. So this is the left subtree for this cat node and right subtree is right child is hash. Okay, then we need to give numbers for the nodes, leaves. Okay, leaf nodes. So 1, 2, 3, 4, 5. Then the second step is we need to construct first position and uh, last position with the help of nullable. Okay. So to find first position and last position, redraw the same syntax tree. Okay, now we need to mark a first position in the left side of each and every node. So first the leaf node, and we know that for the leaf node with position I, first position of that node is the same position itself. Okay, similarly for B, it's 2. This A, 3. Then for this B, it's 4. Then for this hash, it's 5. Okay, now we need to mark first position for the interior nodes. So first we will mark here. First position of the star node is first position of its child. So 2. Then this cat node. Okay, so to find first position for the cat node, we need to do first position of no. If we want to find first position for the cat node, we need to check whether nullable of this node is C1. Nullable of C1 is true or not. Okay. Since nullable of C1 is false. Okay. Because a leaf labeled with any symbol means it is not nullable. Okay. So since it is false, we need to mark only one. Okay, the first position of n will be first position of C1. Okay, so if you want to find first position for cat node, we need to check if nullable of C1. Okay, nullable of C1 is true or not. If nullable of C1 is true, then first position of root will be first position of C1 union first position of C2. But here it is false. So first position of N will be first position of C1 alone. Okay. Now this concatenation node. So here also we need to check whether this node is nullable or not. Nullable of C1. Here also it is false. So nullable of this node is first position of this node is first position of C1. So here we will get 3. Okay. Next, R node. To find first position for R node, we need to write first position of C1 union first position of C2. So 1, 3. Then cat node. So to find first position of this node, we need to check whether this node is nullable or not. If nullable of C1 is true or not. Okay. So if this is true, both either C1 is true or C2 must be true. Okay. So here both are cat node. Okay. So if this node is true means this node to be true, both C1 and C2 must be true. We know that C2 is true, but C1 is not true. Okay. So since both are not true, we can say that this is false. Okay. So this is false means nullable of C1 is false. Okay. So so for this node, nullable of C1, this is false. Okay. So if this node is nullable means either this node or this node must be nullable. Here we know that this node is not null. So at least we need to check whether C2 is null or not. Okay. Since C2 is also cat node, we need to check both the nodes are nullable. Both C1 and C2 are nullable. We know that a leaf labeled by any symbol means it is not null. Since both are not null, according to cat node, it is not null. This is also not null. Okay. So here both C1 and C2 are null for this the union operator. So we can say that this node is also not null. Okay. So for this cat node, nullable of C1 is false. Nullable of C1 is false means first position of this cat node is first position of this C1 alone. So 1, 3. Then we need to find follow position for all the nodes. Sorry, last position for all the nodes. Last position means for the leaf nodes, we have to mark the same. Okay, because last position of a leaf labeled with any other symbol is the same position. Okay, so we have to write the symbol as it is. Then interior nodes must be found. So first star node, last position of star node is last position of its child. So it's 2. Then this cat node. Okay, so for this cat node, we need to check if nullable of C2 is true or not. Okay, nullable of C2. Star node is nullable only. So since it is true, first position of N will be last position of C1 union last position of C2. So it is 1, 2. Then this cat node, to find first position of last position of this cat node, we need to check whether nullable of C2 is true or not. We know that nullable of this node is false. Okay, since it is false, last position of this node is last position of C2. So we have to just copy 4 alone. Okay, then R node. For R operator, last position of this node is last position of C1 union C2. So 1, 2, and 4. Then cat node. To find last position for this cat node, we need to check whether nullable of this node is true or not. Since this node is not null, we have to copy only 5 to this. Okay. Next, third step. Third step is we need to find follow position. So to find follow position, we need to mark all the nodes here. So 1, 2, 3, 4, 5. And if we want to find follow position, we need to check only the cat node and star node. Okay, if we check from the bottom, we will get this star node first. So to find follow position of this last. Okay, last position of this node must be substituted to um, so in star node, uh, follow position of last position of n is equal to first position of n. Okay, so this must be substituted to this. So 2 in 2, follow position of 2 is equal to 2. Okay, then cat node. Okay, in cat node, we need to consider C1 and C2, and we need to consider last position of C1 and first position of C2. Okay, first position of C2 must be substituted to follow position of 1. Okay, so follow position of 1 is equal to 2. Okay, then this cat node. Okay, for this cat node, we need to consider the C1 and C2, and um, 4, first position of C2 must be substituted to follow position of 3. So 4 must be substituted to 3. Next, we need to consider this cat node. So here first position of C1 is this one. Last position of C1 is this one, and first position of C2 means this one. So this value must be, first position of C2 must be substituted to follow position of 1, 2, and 4. So 5 must be substituted to 1, 2, and 4. Okay, 5 must be substituted to 1, 2, and 4. Okay, so that's all. We have checked all the cat node and star node. So this is the follow position. Next, we have to construct DFA for our given problem from the follow position. So to draw the DFA, what is our start state? First position of the root will be the start state. So 1, 3. 1, 3 is the start state. Okay. Then from this 1, 3, we need to check what are all the states containing A. Okay. From 1 and 3, both the 1 and 3 containing A. Now we have to check follow position of 1 and 3. Follow position of 1 and 3 is 2, 4, and 5. So it's a new node. So we have to go to 2, 4, 5. From 1 and 3, A goes to 2, 4, 5. Then in 1 and 3, there is no B. So there is no transition from 1 and 3. It means that it is going to the dead state. Okay, if we want, we can construct a dead state, or we can leave it as it is. Okay, then from 2, 4, 5, in 2, 4, 5, 2, 4, and 5, there is no A. Okay, so there is no transition on A, or we can draw it to dead state. Okay, it's your wish. Then in 2, 4, 5, B appears in 2 and 4. Now find follow position of 2 and 4. It's 2 and 2 comma 5. Okay, so 2 comma 5 is a new state, and from 2 and 4, B goes to 2, 5. Then out of 2 and 5, there is no A. So there is no transition on A. Okay. Now B. In 2 and 5, B appears in 2. Follow position of 2 is 2 comma 5 itself. So it is a self transition. Okay. Now we need to mark all the final states. So final state means position associated with hash. It's 5. So all the states containing 5 are the final states. So 2, 4, 5 and 2, 5 are the final states. Okay. Here there is no transition on B. Here there is no transition on A. And from this state also there is no transition on A. So if you want, we can draw dead state, and we can draw state B. from here you have to draw state B, from here you need to draw state A, and so on. Okay, it's your wish. We can leave as it is. Thank you.